So good afternoon, everyone, and welcome to today's class. This is lecture number 4 in what chapter on capacitance, and we are dealing with problems on capacitance. In the previous class, we had seen the concept of parallel plate capacitor. We had seen on what all factor it depends on, the capacitance of a parallel plate capacitor, and we had seen the different formulae. Do we remember these formulae? Yes or no? The formulae for capacitance. Do we remember these formulae? And we had solved some questions based on this. And I will again continue some questions so that you get used to this. 3 or 4 questions we will solve and then we will move ahead. I know that these type of questions are going to come on your exams and you have to be thorough with these questions. So here comes the first question. And tell me the answer for this one. On increasing the plate separation of a charge condenser, is energy. What happens to the energy? Okay. This energy will decrease or increase? Now, if the conductor is charged, we will always assume that its charge is constant. So remember this. Conductor is charged and the charge on the conductor is constant. On increasing the separation of the plates, what will happen to its energy? Can you tell me? What happens? Anyone? Okay. Anyone knows the energy of a capacitor? Anyone knows the energy of a capacitor? Well, no one remembers the energy of a capacitor. Okay, I'll give you 5 minutes. Go through all the formulae once again and tell me the energy of the capacitor. I'll give you 5 minutes. Please go through the formulae. So here you have to apply. I'm very disappointed with your answers. Energy of a capacitor is, I can write it as Q square by 2C. Now, here Q is remaining constant. So energy is inversely proportional to C. What happens on increasing the plate separation? Capacitance of a capacitor is epsilon naught A by D. On increasing the separation of plates, capacitance decreases. Plate separation is increased. So capacitance decreases. Capacitance decreases. So energy would increase. And that was the answer that I was looking for. Energy increases. And it seems that you still don't know the formula for capacitance. That is a very big shock for me. And I will give you 5 minutes to go through all the formulae. Which formulae you have to go through? How many formulas have we done till now? Please tell me. Forget about the formula of spherical and cylindrical capacitors. How many formulae have we covered today up till today? Do you remember? No one remembers how many formulae we have covered. Okay, great. How many formulae we have done? You don't even remember that, beta? How many? How many formulas have we done so far, beta? Anyone? Okay, well done. The first formula that we had done was charge on the capacitor, Q is equal to CV. I hope you remember this. So this is the first formula that you will have to remember. The second formula that you have to remember is the formula for energy, Q square by 2C half CV square half QV. Then we had done this parallel plate capacitors, and in this parallel plate capacitors we had seen the capacitance of a capacitor is epsilon naught A by D, and then we had seen the different variations of the same formulae. Well, if you don't remember the basic three formulas, I can't expect you to remember the other ones. But even if you don't remember the other ones, you should remember these basic formulae better. Without remembering these basic formulae, you will not be able to solve any question. So I'm highly disappointed, highly dejected, but still I'll give you 5 minutes. Go through this entire chapter. How many of you have read this chapter before coming to the class today? No one has. Good. No, not a problem. Whatever we have done, I have highlighted it to you. I'll give you 5 minutes. Please go through them and then we will proceed with the class. Okay. I'll give you 5 minutes. Go through them. We begin with this question. Question number 2. The capacitance of a parallel plate capacitor is 12 microfarad. Distance between the plates is doubled and area is halved. What is the new capacitance? What is the answer for this one? I'll give you 2 minutes to give me the answer. Yes, anyone with any answer? No one with any answer, so I'll give you the answer. Capacitance is epsilon naught A into epsilon naught by D. In first case, if I call the capacitance as C1, area is A, distance is D. In second case, if I call the capacitance as C2, area has become A by 2, distance has become 2 times D. So I can see my capacitance C2 is epsilon naught A by 4D. So it becomes 1 by 4 times. So C2 becomes 3 microfarad, and 3 microfarad is my answer. Well done, Abhinam. 3 microfarad is the answer, beta. Please note it down. I'll give you a minute. So this is the question. The next question. Capacitance of a parallel plate capacitor is 15 microfarad. Distance between the plates is 6 centimeters when it is 15 microfarad. Now the distance is reduced to 2. You have to find out the new capacitance. Yes, I have an answer. What is the answer?
Option C, sir.
Option C. The distance has become 1 by 3 times, so the capacitance will become 3 times. That is absolutely correct. Well done. Let me give you one more question on this. Let me find out similar question. Where is that? Okay, this one. This one is the next one. The capacity of a condenser in which a dielectric of dielectric constant 5 has been used is C. If the dielectric is replaced by another dielectric with constant 20, what will be the capacity? I'll give you 2 minutes to give me the answer. And the answer is, when the dielectric constant was 5, the capacitance was C. Now the dielectric constant is 20, it is 4 times, capacitance will become 4 times, and the answer is 4C. So that is the answer that we are looking at. When we insert the dielectric inside the capacitor, how does the capacitance change? Ck with the dielectric becomes K times C. So be careful what we are writing. K times C. So when the 5 dielectric constant 5 capacitor was there, it is 5 times C. When the dielectric constant 20 dielectric is inserted, it will be 20 times C. So how much time it has become? It has become 4 times the capacitance C. I don't know how did you get, which option you were getting? C. I don't know how you were getting this C option. Anyways, I hope you understand this beta. Please remember it. Do we remember the formula of dielectric constant beta? Yes or no? What mistake we are
He
making?
told that option A, sir, not C.
Okay, option A. Even option A, how did you get option A? How did you get it divided? So you must be careful in the ratios beta. These are the type of questions that are going to come, and I don't expect that we cannot be doing such questions. So these are simple questions. You just have to find out the say ratio, and I think that you need more practice on this. So please do more practice on such questions beta. Okay, I'll give you one more question. Okay, this one. I'm trying to cover all questions, and I hope that you are able to solve them. I'm not getting confidence in your question solving ability. Once I get confidence, I will be more happy. So this is the next one. There is an air-filled 1 picofarad parallel plate capacitor. When the plate separation is doubled, so plate separation is doubled, and the space is filled with wax, the capacitance increases to 2 picofarad. What is the dielectric constant? I'll give you 2 minutes to do this. So this is the new question. Parallel plate capacitor has a capacity C. Separation is doubled. Dielectric is inserted. The capacitance becomes 2C. What is the dielectric constant? I will give you 5 minutes, 2 minutes to do this.
Option B.
Option B, 1. Great. That is not the right answer. The question is exactly
Option
same.
C, sir.
The question is exactly same as this question beta. Nothing has been changed.
Option C, sir.
Only instead of 1 picofarad, in place of 1 picofarad, it is given as C. In place of 2 picofarad, it is given as 2C. The question is exactly same. So the answer here is option C. When the plate separation is made twice, the capacitance becomes half. And now a dielectric is inserted. The capacitance becomes 2 times. From half, it becomes 2 times. From half, it becomes 2 times. So the dielectric constant has to be 4. Is it difficult for you to understand, bacha?
Yes, sir.
Difficult to understand? Are you able to understand this, or it is difficult, beta? That is what I'm asking. Are you able to understand this? Yes or
Not
no?
understood, sir.
Yes, beta? Not understood? Not understood? Okay,
No, sir.
then I'm not able to understand whether you are able to understand it or not.
Understood, sir.
Pakka na?
Yes, sir.
Okay, then I'll give you one more question because I'm still not confident about your answers. So I'll have to give you one more. Unless until I get confident, I just can't move ahead because I'm not getting the confidence from your answers. First of all, you are taking a lot of time. You should not be taking that much of time. And you are taking a lot of time. I think you should be able to do them more quickly. So, I should give you one more question. I'm looking for a question that I can give. Okay, let us see how you can do this one. And I hope that you can give me an answer confidently and quickly. This one. If a slab of insulating material. No, you will not be able to do this now. So I'll have to take this out. You will not be able to do this because it's something that I have not told you still. Where is the question? I can't find a question. Shameful. Okay, then I will make a question on my own. So now answer this question. Question number 7 or 8, whatever it is. The area of the plates of a capacitor is halved and the distance is doubled. Find the ratio of old capacitance is to new capacitance. I hope you understand the meaning of this question. Yes or no? Okay, I'll give you 2 minutes to solve this.
1:4, sir.
Okay, so how are you going to do this? If I call the original capacitance as C, that is epsilon naught A by D. Now, if I call the new capacitance as C1, epsilon naught area is halved, so A by 2. Distance is double, 2D. So new capacitance becomes epsilon naught A by 4D. Now I find the ratio C by C1 and it will be equal to 4:1. Old capacitance divided by the new capacitance is 4:1. That is how you have to do it. Do we understand this? Okay, well done. So I will finish this class here today. I was supposed to do series and parallel combination, but we could not do this because we were stuck into problems on this. I hope we have done enough problems. I've covered all the problems that have come till now. And you will find one of these problems in your paper, be rest assured. So I'll wind up this class here. Everyone has understood what we have done? Anyone having any doubt? Great, well done. So we will continue with the class in the next class. Take care and God bless you all. Bye bye.